Alright, hello once again, Jeff Scott of Rankin Technical College, and I've been going through a series of video presentations for the Rankin Technical College AWD1100 C# programming class. The book we're using for the class is Muroc C# 2015, and I'm going currently through the object-oriented programming section, and I've done chapters 12 and 14. We're skipping 13, so I'm going on to chapter 15 right now, which is on interfaces and generics. Our applied objectives: use .NET interfaces as you develop classes for an application, develop and use your own interfaces. And our knowledge objectives: distinguish between an interface and an abstract class, describe the use of the .NET cloneable, comparable, and enumerable interfaces. In general terms, describe the use of generic interfaces. Alright, well, don't know if this picture is going to actually resonate the way that I want it to, but we're going to try something here anyway, and that is I'm just going to come in here and start up a new document, go in and grab some, insert some shapes. Let's see, do we have anything in here that I'm looking for? Well, don't know if it'll work or not, but let's try this. Okay, and let's take this, and we will take this. Okay, when I put them together, as you can see, it makes a diamond. Alright, now let's suppose that I have two classes here. So I have class 1. It doesn't matter what the class is about or anything else. And class 2. And what I want is this here is going to be a class as well. Alright, and I want it to inherit from both of these. So in other words, I want to be able to grab information, etc. from both classes. So I want to be able to do this, and also maybe I can just do this one again. Copy, paste, there we go. Thought I could maybe just grab one end of this and spin it. There we are. So this is what I would like to do. I would like this class that I'm about to create right here, I'd like it to be able to inherit from both class 1 and class 2. As I've shown right there, that results in what's called a diamond effect. Let's suppose we didn't do a good job and we had fields in here with the exact same name as fields in here. It is possible the compiler could get confused and not know which class these were coming from. So, long story short, when you are working with the C# programming language, it only allows for single class inheritance, not multiple class inheritance. You cannot do this. Okay? Now, what's the fallback, so to speak, from that? There really isn't any, because of the fact that although you can only inherit from one class, you can implement from as many interfaces as you want. Well, that's an important concept. I just want to say it one more time. That is, you can inherit from 0 or 1 class only, but you can implement 0 or more interfaces. All right, and that ends up becoming a fairly important thing to realize. Okay. Now, when you work with interfaces, interfaces in many ways are like classes, but they're not a class. All right, hence the name. They're an interface. So, notice what we have here. We've got a product that implements the iDisplayable interface. Okay, that's just fine. Here was the iDisplayable interface. All this says is that any class that implements this interface must provide a getDisplayText method. It must return a string, and it must take a string in as a parameter. And as you can see, this one does. Now, fortunately or unfortunately, for example, in the Java programming language, when you're working in Java, this says class product, it would say extends this. And for an interface, it would say implements this. Really, the only way that you can tell that this is an interface as opposed to a class is by convention. Interfaces begin with a capital I. All right, so I can look at that and say that's the iDisplayable interface. Other than that, it's very similar to a class. All right, so if I come in and create a new product, I am able to call that particular product's getDisplayText. Okay, so let's compare and contrast interfaces and abstract classes. Both of them provide signatures for properties and methods that a class must implement. So in other words, if you add a method to either an abstract class, if you add an abstract method to an abstract class, or if you add a method to an interface, and you've got a class later that either implements that interface or inherits from that class must provide that method or those methods that were in the interface or were in the inherited class. Secondly, all members of an interface are abstract. In contrast, abstract class can implement some or all of its members. What does that mean? That means that everything in an interface is abstract. You don't have to say it. However, for an abstract class, you can have things in there that are not abstract. Third, a class can inherit only one class, but it can implement 0 or more interfaces. Finally, interfaces can't declare static members, although abstract classes can. Here are some of the built-in .NET interfaces. All right, the one that we have actually used in this class has been iComparable, which allows you to compare two objects. If the objects are equal to one another, a 0 will be returned. If the first object is, quote, greater than the, unquote, the second object, 1 will be returned. If the first object is, quote, less than, quote, for the second object, -1 will be returned. But there's a clonable, a convertible, and a disposable interface as well. There's even more when you start getting into collections. Again, notice they all start with I. So if you want to create your own interface, rather than saying public class, it's public interface. You give the interface a name. As it says, you can add methods, as many methods as you want. Those methods can or cannot, depending on how you want it set up, have parameters. And an interface can also have properties. So here's an interface that defines a single method. That's the one you saw earlier here. The second one, the one on the bottom, the iPersistable, what does it do? It defines two methods, a read method and a save method. And in addition to that, it has a hasChanges property. So in many ways, these work in a very similar way. Not only that, an interface can inherit other interfaces. All right? It gets a little bit confusing after a while, but the idea is the language is, like most programming languages, is meant to be as extensible as possible, meaning that if you want to add to it by taking what's there and combining things together, you're able to do so. So again, when you implement an interface, it looks virtually the same with a colon as inheriting from a class, except the interface name starts with a capital I. And here's an example of implementing more than one interface. Here's an example of inheriting from a class and implementing two interfaces. You can use that quick actions menu that we talked about before to have some of the stuff built for you automatically. You'll notice that when you do that, as it says there, the code that's generated when you implement the interface, by and large, isn't going to be what you want. So whether it's an interface or whether it's a class, if you have it generated for you, if it's just going to throw a new non-implemented exception, you probably want to, one of the first things you want to do is remove that code that's in there. The code for the cloneable product class, now remember, cloneable. All right. What's different from this as opposed to what we saw before? The answer is twofold. It is in implementing the iDisplayable interface, and it is implementing the iClonable interface. So how do we clone? Basically, when you clone, you're making an exact copy. All right. Now, if I go in and I create a simple variable, if I say int age equals 21, then I say int age 2 equals age 1, I'm just copying the value from one to the other, and that works fine for scalar values. But when I'm working with a class can have several members. So you see this clone interface says I have to create my new product in this case, and then copy over the code, the description, and the price. Here's some code that's shown here that both creates and clones a product object. So here's the first one. Here is the second one. A CreateList method that uses an interface as a parameter, so this stuff can be passed in. Here's another one. And there's code that uses those methods. Now, because of time and a lot of other things, we're going to look at some of these, but we're probably not going to use these in as much detail as I'd like to. The good news is, fourth semester, we'll go back and we'll look at using lists and etc. again under the auspice of using it in Java. All right. So the other part that's discussed here is generics, but we are already at about 15 minutes. So I'm going to stop for this lecture, and we will pick it up in just a couple minutes.